I don't want to leave you hanging with this last problem. I know I said I would talk about it in class. But just real quick, the final answer, letter C, is so you could figure out the probability of getting exactly 2 hits, whether they're in a row or not, would be 1/4 squared, and then times, what was it, it was 3/4, wasn't it? Because that's a probability of not getting a hit, but then you have to multiply by 3 because there were 3 different ways of doing that. So 9 out of 64, or if you change that to a decimal, about 14% chance that I like to round to 3 decimals. You guys are probably sick of hearing me say that. So 14.1% is a fine. That's still rounding to 3 decimals because it's a percent. So where is the connection to a binomial expansion? I'm going to try and keep this simple, but there's a lot to explain. So in a probability that's a binomial, that means you either have a success or a failure. There's no other possibilities. So how is that connected is that when you look at a probability that's a success or a failure, that means the sum of these two numbers has to add to equal 1. So, but it's we use P and Q for the probability of success and a probability of a failure. But as you take it to the nth power, what you could do then is realize that, okay, well, you could have all situations be a success. Well, if all of the situations are a success, that means that you have that NC0, because there's only one way for all things to be a success, and then you'd have to find the probability of success to the nth power. And then the next one would be NC1, because you want all of them to be successes except for one failure. So that's why you would do P to the n-1 power, because you want all but one to be a success, times Q to the first power. And ... all the way until you get to NCN of all the failures being an option. And the reason why this is still a true statement is we have covered every scenario. You've either all success, all but one success, all but 2 success, all but 3, all but, until you all fail. And the reason why these two things are equal and there's still a probability, because remember, you either succeed or you don't, which means that this is the same thing as 1 to the nth power, and will be my last statement, is 1 to any power is equal to 1. Well, that needs to be the sum of every scenario, because you either all succeed or you all but one succeed, and I'm sure you're tired of hearing me say that. So I'm going to make this an extra video at the end, because I can talk about this in class as well, and I realize that this very short 4-minute explanation might not satisfy your understanding of how this is a connection to the binomial expansion. But thanks for watching if you stuck around.